All right, so if I am completing the square for number 8 here, what's my first step? Add the 1. So I'm going to do 3. All right, I added the 1 to the other side. Now, there's choices here, right? What's one of the choices I could do moving forward? I could divide everything by 3. Divide by 3, divide by 3, divide by 3. And I'd get x squared minus 4/3 x equals 1/3. The other thing you can do is take out the 3 and put it on the front of the parentheses, right? And then work forward from there. If you divide everything by 3, you're here. Now I have to take this middle term, divide it by 2, which is the same thing as multiplying by a half, and then squaring it. 2 goes into 4 twice, and I get 2/3 squared, which is 4/9. I'm going to add that to both sides of my equation. Now I'm going to factor the left side. This is a perfect square trinomial. That was the whole point. So we factor by square rooting the first term, square rooting the last term, and taking the sign from the middle, put it in the parentheses and square it. And then I have to combine together the 1/3 and the 4/9. So this would have to get the same denominator. That would be 3/9 plus 4/9, which is 7/9. We good so far? Yep. Now I'm going to square root both sides, and when I square root both sides, I have to make sure I do what? Plus and minus. So I'd get x minus 2/3 equals plus and minus the square root of 7, which doesn't get reduced, over the square root of 9, which is good. Then I would add the 2/3, and I could write my answer a couple of different ways. 2 plus and minus square root 7 over 3, plus and minus square root 7 plus 2 over 3, or I could keep it separate, 2 minus square root 7 over 3, and 2 plus square root 7 over 3. Any one of those formats would be acceptable on a quiz or test. Sophia.
I thought you had to subtract the 4/9 from both sides.
Subtract the, which one?
For the part in green.
Yeah.
Subtract the 4/9 on both sides?
This part? Like that 4x?
Yeah, like that part.
No. You add to both sides and then factor. You're trying to put it in a different form. So what you're doing here is forcing it into a perfect square trinomial so you can factor it to be something squared. So that's the goal. So we get rid of it from here to here because we factor that. We just use the shortcut to factor.
Oh, was it a minus 4/9?
No. You square it, so it's always going to be plus. So you add it to both sides. Yep. All right, we're going to do one more. Yep. Let me know when you remember. Okay. Did anybody take the 3 out and then have to multiply it before they added it to the other side? Just in case. Okay, so I'll do that format on the next one. Okay, just so that you can kind of match it up. Yeah.
When you write it wrong, I put x equals 2 over 3, and then
Plus and minus root 7 over 3? No. That's perfectly fine. Okay, so this one, let's say we take, first we're going to bump the 1 to the other side. Then we take the 5 out, and I'd get x squared minus 7/5 x equals 1. Then I take 7/5, I divide it by 2 or multiply it by a half. And then squared, I get 7/10 squared is 49/100. So I'm going to add the 49/100 in here. I would add it over here, but because we didn't divide by that 5, I have to multiply by 5 first. Then the 5 goes into the 100 20 times, and I would be adding 49 over 20. So now I'd get 5 still there, x, take the sign from the middle, square root the 49 over 100. This becomes 20/20ths, and that's 69/20ths. Then I have to solve by dividing both sides by 5 or multiplying by a 5th. And I get x minus 7 over 10 squared equals, wait, what did happen? Hang on. Oh, no, I'm good. I'm thinking I'm comparing it to the first question. It's supposed to be the same. It's not supposed to be the same. 69 over 100. Then I square root both sides, putting the plus and minus in front, and I get x minus 7/10 equals plus and minus square root 69 over square root of 100, which is 10. Add the 7/10. So I'd get 7 plus and minus the square root of 69, which just breaks down. If I wanted to try 3, it would go 23 times. That doesn't break down. So all of that goes over 10. Yeah. Sure. So move the 1, right? 5x squared minus 7x over, or equals 1. Divide everything by 5. X squared minus 7/5 x equals 1/5. 7/5 divided by 2 times a half squared is still 7 over 10, still 49 over 100. This time I just add it over here. I don't have to multiply it times anything. Say again. Like on this process, we have to multiply it by the 5 first. On the right-hand side, you don't. So I'd get x minus 7/10 equals, and then this becomes 20, so 4/20. No, not 100. I would have to multiply it by. So it's 20 hundredths. And it's still the same, 69 over 100. So now I square root both sides, putting the plus and minus in front. And then add the 7/10. You're welcome. That way or that way. Keep it separate, combine it together, it doesn't matter. Just don't forget your plus and minus.
Can you do
Jensen.
number 6 on the homework?
Sure. Can you read it to me?
Sure.
Faster.
4x squared minus 4x equals 1.
Okay, so they already moved the 1 to the other side. So do you divide or do you take it out? Divide. So get rid of all the 4's. X squared minus x equals 1/4. So now I've got a 1 here. 1 divided by 2 squared would be 1/4. Add it here and here. Square root, sign from the middle. And 1/4 plus 1/4 is 2/4, which is 1/2. You could keep it as 2/4 because you're going to square root it. So we're going to end up rationalizing this anyways. If you have like that foresight to keep it, you can. Because what's going to happen here is when we square root, I end up with x minus 1/2 equals plus and minus. It would be 1 over root 2. And that has to get rationalized. So I'd do root 2 over root 2. And that's plus and minus root 2 over 2. Then I have to add the 1/2. So I'd get, here, let me write this in different colors so it's easy to read. X equals 1/2 plus and minus square root 2 over 2. Or 1 plus and minus root 2 over 2.
Thank you.
You're welcome. So that's the only benefit to not reducing that is that bottom is already a perfect square, so you can square root it if you plan ahead. If you don't catch it, you're just rationalizing it. But if you can do that, then you don't have to simplify and then rationalize.
Could you do it on the other?
Sure.
Take out the 4.
Okay, take out a 4. Still -1, right? So still 1 divided by 2 squared, still 1/4. Add it. I would add it over here, but I have to multiply by the 4 first. So I get 4x minus 1/2 squared. These cancel, and I'm adding 1. Then I got to divide both sides by 4. So again, you can keep it as 2/4 because we're going to have to square root it in a moment. Or you can simplify. Did you simplify?
No, I forgot to divide by the 4.
Okay. So if I kept it as 2/4 here and then I go to square root it, I'd get x minus 1/2 equals plus and minus root 2 over 2 and then add the 1/2.
Okay, thank you.
You're welcome. Any other questions from the homework? Yeah.
Can you do
9. Can you read me what it is?
4x squared plus 10x equals 16?
Equals 16. Do you take out the 4 or divide everything?
Divide
Okay. So this would be 5/2 and 4. So then I take 5/2, divide it by 2 or multiply by half and square it. 25/16. So factor, sign from the middle. This becomes 64/16. Then square root both sides. Oh, square root of 16, which is 4. And then subtract the 5/4. You're welcome. Good. So complete this square will be on your test, which is like the end of next week. It's not on your quiz, okay? Test is a week from tomorrow. It's not on your quiz. Bump the 9. Divide by 7. Take the 2/7, divide by 2 or multiply by a half, and then square it. Add it here, add it here. Factor this. Multiply by 7, that's 63/49. 64/49. Square root, plus and minus. That's 8/7. Add the 1/7. And I get x equals, now this can actually be worked out because 1/7, there's no fraction, I mean there's no square roots here. So this is 1 minus 8/7, and this is 1 plus 8/7. -7/7, which is -1, and 9/7. So if there's no root left in your answer, you got to keep going. You're welcome. Oh, that's what I meant to do. On your quiz is the stuff that was on this quiz review. So this first page was 1 to B, right? Remember I said yesterday there's really only like one little bit that comes from 1 to A, and that was like solving an equation where you have to like distribute with your parentheses and stuff. So I put that, this one? Yeah, okay. So my least common denominator here, there's nothing to factor. So least common denominator would be 6k squared. That's what all three of them go into. Biggest number and highest exponent on the variable. So I'm going to multiply 6k squared here, 6k squared here, and 6k squared here. From the first one, the whole thing cancels, so I have just 1. The second one, 3 goes into 6 twice, and both k's cancel. I have 1 times 2, or 2. And the last one, only 1k cancels, and I get minus 1 times 6k, which is negative 6k. Subtract the 2. Negative 1 equals negative 6k. Divide by negative 6. And k equals positive 1/6. The only thing that would have gotten eliminated here would have been a 0, so I get to keep the 1/6. Other questions? Yeah.
On the second part.
Okay, so factor your denominators. The m's going to come out here, m minus 1. The next one is already factored. The last one, the m's going to come out of here, m minus 1. So my least common denominator is m times m minus 1. I multiply it times each of these 3. The whole thing cancels from the first fraction, and it's just 1. just the m cancels here. 1 times m minus 1 would be m minus 1. Whole thing cancels again from here, and it's just 5. Negative 1 and positive 1 cancel, and I get m equals 5. Good. Make sure you check it, though, right? So this can't equal 0, and this can't equal 0, which means I couldn't have 0, and I couldn't have 1. M equals 5 is okay to keep.
Can you also do number 19 of the first section?
Yep. I think I added them on. On the bottom down here, that's your 1, 2a. There won't be a fraction in which there's only numbers in the bottom. There's going to be fractions that are variables in the bottom, which came from 1, 2b. And then, okay. So the first thing we have to do here is factor, right? X and then x minus 5. And then for these, don't forget you're going to have to check for your extraneous roots. So I would do it from the beginning. Just say that neither of these can equal 0. It repeats over here, so it's just the same thing again, which means my answer can't be 0 and it can't be a positive 5. So keep a little note of that off to the side to remind yourself to check your answers when you're done. All right, so now I've got factored my denominators. I have to find my least common denominator, which is going to be x and x minus 5. I would multiply all 3 terms by it. From the first one, both x and x minus 5 cancel. So I just am left with 1 equals. The second one, the x's cancel, and I'm left with x plus 7 times x minus 5. And the last one, nothing cancels. 1 times x would be negative x times x minus 5. So now I've got to FOIL and distribute. So I get 1 equals, this would be x squared minus 5x plus 7x minus 35. So x squared plus 2x minus 35. This negative can go with the x because it's got to get distributed to both things. So that would be negative x squared plus 5x. The negative and positive x squareds cancel out. And I get 1 equals 2x plus 5x is 7x minus 35. Add the 35. 7x equals 36. Divide by 7. And x equals 36 over 7. Check to make sure that's not one of your exceptions, and it's not, so you keep that answer. You're welcome. Any other questions from the quiz review?
Can you do number 6 on the second part?
All right, factor p plus 1, factor p plus 1, and that one's already factored. So if I check, p can't equal 0, which means I can't have 0 as an answer, and p plus 1 can't equal 0, which means p can't be negative 1. So those are the two things I can't have. Multiply it times all of them, p and then p plus 1, p and then p plus 1, p and then p plus 1. Cancel the whole thing here. I have p plus 5. Whole thing here equals 1, just the p plus 1 there, and I get minus p minus 6 times p. So p plus 5 equals 1. This p is going to get distributed. Minus p squared minus 6p. That minus goes to both. As soon as you see there's a p squared and a p, I know I'm going to have to factor this. So I'm going to get everything to one side, and I prefer the squared term to be positive. So I'm going to move from right to left. I'm going to subtract the 1, add the p squared, and subtract the 6p. So I end up with p squared minus 5p plus 4 equals 0. I'm running out of space, so I'm just going to write this over here. And then I've got a factor. So I'm looking for the factors of positive 4 that sum to negative 5, which would be negative 1 and negative 4. Split and solve. P equals 1 and P equals 4. From the beginning, we said p couldn't be 0 and it couldn't be -1, but 1 and 4 are both okay to keep. Richard?
So if one of them did equal 0 or -1, what would you put?
Just cancel out the one it can't be and keep the other one. Yep. You're welcome. Other questions? Samuel.
Can you give me 10 from the homework for like?
Then came this. There's a solution for it. Then came 1, 4a, which was solving. This is all using square roots. And then this part?
Yeah.
Yeah. All right, so for 6, this is your square root one, right? Or using the even root property. Before I can square root it, I got to get rid of the -2 on the front. So I divide both sides by -2. And I get x minus 3 squared equals -20 divided by -2, positive 10. Then I square root both sides, putting the plus and minus in front of the 10. X minus 3 would equal plus and minus square root 10. And then add the 3. And I get x equals 3 plus and minus square root 10. Or plus and minus square root 10 plus 3. Either one works.
For the
Jensen.
extraneous roots one, if one of them was 0, it just cancels out that possible answer. not the whole
Correct.
thing, right?
So if you were using on the last one, it couldn't be like x couldn't be 0 and x couldn't be 5. And for answers I got 4 and 0, I would cancel out the 0, but I'd be able to keep the 4.
Okay, thank you.
You're welcome.
Also, 21 can keep it.
Correct. Don't forget to check for those, because it's not like there's going to be something that's like, hey, don't forget to check me. It doesn't happen, okay? If there's a variable in your fraction, circle your number to remind you to go back and check those. Yeah.
Can you do number 1?
From which one?
No question. For like number 1, would you subtract the 6 before you do the square root?
You have to. So you can't square root until that term is completely by itself. It's got to be isolated. So you'd have to subtract the 6, and then I'd get k squared equals 0, square root, and I'd get plus or minus 0, but it's still just 0. Yep.
Can you remember it on the first one?
On the first one, I'm solving using factoring. So questions on any of these, Sophia?
Can you do number 17 on the first section?
On the first